Hello Gate passengers, welcome to GATEBus. In this video, we are continuing our Gate question series. So today's topic is traffic signal design. In that, our first question. For an approach road on a signalized intersection, average delay per vehicle is 12.5 seconds. The red time is 30 seconds and cycle length is 60 seconds. Find the saturation flow. The vehicle arrival rate is 20. So we have these values. Now, to solve this question, we know that average delay per vehicle is equal to C by 2 1 minus G by C 1 minus Q by S. Okay. C is equal to cycle length and G is equal to green time and Q is equal to, here you get square, and Q is equal to vehicle arrival rate, right? Okay, and S is equal to saturation flow. Okay. So now we know C, Q, S, but we don't know G value, right? So green time is equal to cycle length minus red time. Okay. So R is equal to red time. So you got 60 and 30. That gives 30 seconds. So we got G as 30. So by plugging all the values, that is 12.5 is equal to 60 by 2 1 minus 30 by 60 whole square by 1 minus Q is 20 by S. So we got, this is half, square means 4 means 30 by 4, so 1. So we got 20 by S is equal to 30 by 4 into 1.5. Okay. So what is the 30 divided by 4 into 1.5? That is 0.6. So 1 minus 0.6 is equal to 20S. Right? Our S is equal to 50 vehicle per minute. So then 50 vehicle per minute means 50 into 60, that is 3000 vehicle per hour. Next question. At a point on a road, the probability of time had being more than 12 seconds is 5%. The probability of time had where falling between 8 and 16 seconds is. So to solve this, so probability of headway more than T is equal to e power minus lambda T. Okay. So we know that. So we got for 12 seconds we got 5%, right? So e power lambda 1 seconds is equal to 5 by 100. Okay. So minus lambda, right? Minus lambda means we'll get 1 by E. Minus e power minus, right? So lambda 12 is equal to 5 by 100. That is 1 by 20. For converting E into L, we got 12 lambda as L and 20. So we'll get lambda as that is 0.25. So now to find this probability of time, that is between 8 and 16, right? So probability of t time, probability of headway less than 8 and less than 16 and greater than 8. That is between, that means between 8 to 16, greater than or equal to. So our headway will lie between 8 to 16. So that is equal to e power minus lambda 8 minus e power minus lambda 16. Okay. So by solving this, so we got lambda as 0.25, right? So e power, so e power 2 minus e power 4. So we got about minus signs. So minus 2, right? So we got that is some 0.117, and that is equal to 11.7. That is a question. A three-phased signal is designed with the critical flow ratios as 0.3, 0.3, 0.2 respectively. The last time per phase is 4 seconds. So the effective green time for the last phase is, so we have to find the effective green time for this. This is the last phase, right? So we know that effective green time is equal to C minus L into Y1 by Y. So here C is equal to cycle length and N is equal to lost time, that is N into T. This is per phase, this T, and Y is critical flow ratio, that is Q by S, and Y is summation of small y's. Okay. So we got all these values, right? 0.3, 0.3, 0. So our capital Y will be 0.3, 0.3 plus 0.2, that is 0.8, right? Now in this question we don't know the value of C. So first we have to find C. So C is equal to 1.5 into L plus 5 by 1 minus 5. So putting on the values, 1.5, so L is 3 phase, right? 3 into this 4 plus 5 plus 5, 1 minus 0.8. So by solving this, 12 into 15, 12 into 1.5, so we'll get 115. So now green time, effective green time will be 115 minus 12. We got N as 12, right? So we'll have to multiply it to 0.2 as we're finding for this is Y3. So in this formula we'll get Y3. So we have to put 0.2. So Y is 0.8, right? 0.8. So that will be 115 minus 12 into 0.2 divided by 0.8. We got 25.75. That is option D. So next question. the arrival rate is equal to 800 and saturation is 1800. Find the dead time. The cycle length is 90 seconds and the average delay for each vehicle is half of that time. So in this question, it told that the average delay time for each vehicle is half of that time, right? So average delay time per vehicle is equal to C by 2 1 minus G by C and Q by S square. So in this we got delay time as half that time. So to this be half of that time. Half of that time R by 2. So as it is mentioned, the average delay is half of that time. So then G by C should be equal to Q by S. Okay? Condition. This is the condition. Okay? So now taking all the values in this equation, taking all the values now, you got G 90 agar such as vehicle per hour, both are in vehicle per hour. So 800 by 1800. So about 2 meters and force, and this is 9, 10, and G is equal to 40 seconds. So as G is equal to 40 seconds, R will be 90 minus 40, that is 50 seconds. 40 on the right. So we got option D, 50 seconds. So next question. Assume a traffic highway obeys. Sorry, this is highway. Don't understand. Highway obeys green shield model. Okay. So vehicles are moving from P to Q, right? And it's given that flow and speed 1200, 1800, 60 km, 30 km. So to solve this question, as our traffic is obeying green shield, so it is a linear. So it follows a linear equation also. So Q will be kV, right? That's it. This is flow. Sorry. So U is flow, K is density of traffic, and V is speed of the traffic. So by putting this 12, so we'll get 1200 K1 60. So K1 will getting as 20. So 1800 K2 30. This is as 60, right? You got case. So now in this question, we have to find, sorry, I forgot to mention this, speed of shock wave. Okay, speed of shock wave. So speed of shock wave is equal to Q2 minus Q1 upon K2 minus K1. Okay, so this will be our Q1, Q2. So we got K1, K2. So now putting all the values, that is 1800 minus 1200 by 60 minus 20. We got so we are getting 15 km per hour. So our answer will be 50 km per hour.